Hello, Maurieo! In this question we're going to find the area of the attached shape. As we can see, it's got 1, 2, 3, 4, 5 sides, so it's a regular pentagon. Now to find the area of it, what we do is we break it down into triangles. So we can see here that it's an inscribed pentagon and as it fits inside the circle. So if we just take the red pen here, and I'm just going to draw a line from there through to there, and that breaks it down into triangles. If we take it logically like so, we can see here that we can break it into 5 triangles. 1, 2, 3, 4, 5. So, and each of those triangles will have the same area because the two sides are the same, or these two sides here will be the same. They will both be 8. So, we'll indicate that those two will be the same length. However, they may not necessarily, or won't be the same length as that one there. Alright, so therefore we've got 5 triangles. We break it into 5. We find the area of one triangle, multiply that by 5, and that will give us the area of the shape. Okay, now the information that we have here is we have that side, this side here is 8, this one here is 8, and we don't know what that one is there. So let's draw the triangle up here, a large triangle, something like this. So here's the triangle here. This is what we know right here. We know that that's 8, and we know that that there is 8. We don't know what this is. That's all we know. However, what we do know is that the angles at the centre of a circle add to 360. So angles at the centre equals 360 degrees. So the angles around here, 1, 2, 3, 4, 5, and they are all equal. The angles are all equal. So if we go, we'll call this triangle ABC. So I'm going to call that one A, B, and C, like so. Now we have a little convention in mathematics that we label the angles, so that's the angle A with a capital A, angle B with a capital B, angle C with a capital C, and we label the sides with a lowercase. So the side opposite angle A would be A. The side opposite C would be C. And the side opposite B would be little b. So there we've got our triangle all nicely labelled. Now we know that the angles at the centre equals 360, therefore the angles are all the same, so angle A equals 360 degrees divided by 5, and that equals 72 degrees, like so, 72 degrees. So this is angle A in here. Typically we put a little thing in there. We can put arrows on it if we wish, and we know that that's 72 degrees in there like that. So that's a degree symbol there, in case you were wondering. Okay, 72 degrees. the angle there. So although up to now we've been using the formula of the area of a triangle is a half BC sine A. The area of a triangle is a half the base times the height. In this instance, we don't have a height. Any one of the sides could be a base, but we don't know what the height of the triangle is. However, we do have an alternative equation, and that is that the area of a triangle, area of a triangle equals a half BC sine A, like that there. And that is where the sides are labelled using this convention that I've just said. So in this case here, if we fill in our formula for what we know, the area of the triangle is going to be a half, and remember that that will be a times in there, and B is 8, and C is 8, and the angle A is 72 degrees. Okay, and we can work that out. And on our calculators, and I'm just getting my calculator out now and seeing if I can sort that one out. So, Caltastic on my phone. All right, so a half, well, we can write that as 0.5, 0.5, enter. And now I'm going to multiply that by 8 times, and I'm going to be multiplying that by 8 again, 8 times, and I actually get 32. Half of 8 is 4, 4 8s are 32, and then I'm going to go 72 sine, which is 0.951, and a whole lot of other numbers, times, and that gives me 30, so that's equal to 4.4338 and a whole lot of other numbers. That's more than we know. And in this case here, I'm going to assume that that's meters. So let's call it meters squared. Where no units are shown, I think it's fair to assume that it's meters. But, you know, that's just a personal thing. So now we can then round that to 2 decimal places. No, we won't round that. I'll just undo that now. Okay. And I'm just going to leave that there because that's part of the calculation. What we now want to do is just leave that on our calculator, and the area, and go, I'll just pop over here a bit. Area, oh, that didn't go so well. Like so. Let's get this back here. Get this brush shot as back. 10. Area. Area of the shape, or the pentagon, equals, now because there's 5 of them, 5 times the area of the triangle, and that equals 5 times 30.4330. So all I do is go back to my calculator and multiply by 5 times, and I get 1.1690.426. Okay. And that equals 152.17. Its area, so meters squared, and that will be to 2 decimal places. Okay, I'll just go up here for a different colour and just find area of pentagon. So, find the area of the pentagon. Show. Well, that's clear. Okay, so just to recap, we take our pentagon, it's over here, and we split it into triangles. Because it's a regular pentagon, we will have 5 triangles that each have the same height, same area. Okay, so we know that the angle at the centre of the circle here will have a total of 360 degrees, that there are 5 angles, all of the same. So 360 divided by 5 is equal to 72, so there'll be 72 degrees. Our triangle here will have sides of 8 each side, because they're the radii of the circle, the centre of the circle, and each of the corners of the pentagon are on the circle, so the sides will be 8 and 8. We have a formula for the area of a circle that the area of a triangle. We have a formula for the area of a triangle equals a half BC sine A. So we fill in what we know. We know that it's a half times 8, B being 8, C being 8, times the sine of 72 degrees. We multiply that out, and we get 30.43380 meters squared. We then know that the area of the pentagon is 5 times the area of triangle, the area of the triangle. So we go 5 times that, which is 5 times is 152.1690426, which we round to 2 decimal places, 152.17 to 2 decimal places. And there you are. There you have it. I think that that's a pretty reasonable breakdown of that problem, and covers pretty much everything. All good? Cheers.